All right, welcome to this note or lesson on map and compass. And this is maybe one of the more technical components of outdoor ed and sometimes a more challenging aspect. And it's actually best done hands-on. Unfortunately, this lesson is not a hands-on lesson, but more of a note. And I have provided you a printout that you can use to fill in some of the answers to these notes. So first question I'll ask always is what's at the top of a map? What direction is at the top of a map? And if the map is made properly, it's usually north. I do find that most tourist maps, north can be just about anywhere. It drives me crazy, but that's just the way they do it. For example, the map of Kincardine does not always have north at the top. It kind of uses the lake front. Same thing happens when I go to Toronto and I get a tourist map. But if you're using a proper map that's made for traveling in the wilderness, it will have north somewhere towards the top. Doesn't necessarily always be directly to the top, but it is in the direction of the top. The map will also almost always have a series of lines, northing lines, that if you look for them on the map, you'll see them there. Not sure why this pen's not working for me. Just see if I can get the pen working here. No, doesn't want to. Oh yeah, it is. So northing lines will be like lines that'll be spaced out on the map that'll point in the direction of north. Okay, they're not always perfectly straight up and down like this. Okay, they can be on a slant or an angle a bit. When we look at our Algonquin maps, you'll see that the lines are actually tilted a little bit, sloped, but north is generally to the top of the map. You will find somewhere on a map a compass rose, and this is what a sample of a compass rose is. Compass rose shows you north, south, west, and east, and I really don't feel it's necessary if I have north, but almost any quality map will show what's referred to as a compass rose. All right. When we look at what is true north and magnetic north, these are two different things. So true north is actually what we refer to as like the North Pole. It's where the point where the Earth is rotating on its axis, okay? And for us in the north, that's actually over the Arctic Ocean. It's not over land. But magnetic north is somewhere different. It's actually a spot where the compass needle points. And the reason these are slightly different is that it has to do with the core of the Earth. And there is an outer inner core that is liquid, and that's what causes our our magnetism of our planet. And it kind of that liquid is kind of shifting and moving, and so what we find is that magnetic north itself shifts and moves, but it is a spot where on the planet it's fairly close to true north. I'm going to show you here a map or a little picture, a really good one actually, that shows you where magnetic north is compared to true north. Okay, so geographic north, or what we refer to as true north, is right here. Okay, this there, wow, that's for some reason my pen's not working again. Let's see if it's gonna, no, doesn't want to write there, doesn't want to write here. Just try a couple things here, see if I can get it to work. Here we go. So this is true north. Okay, here is magnetic north. Magnetic north is actually somewhere up in the Northwest Territories. It is shifting and moves. It just moves in a slight distance. It's shifted this direction in recent years and towards the west, and then now I think that it's started to turn and come back to the east. And so it's not a static place, and there are actually calculations on what it's doing and how it's moving. Now, there is something we refer to as magnetic declination. Okay, so magnetic declination is what the difference between magnetic north and true north, and each place on Earth that's different. I can explain this using this map here, or this picture here. So we live, if I can get my best estimate, we live somewhere around, I don't know, in this spot here. That's roughly where we are, okay? I don't know why, but for some reason the dot disappears on me here. And if you were to draw a line that goes like this, that's our direction to true north. And if we draw a line here, there, that is magnetic north. This difference is what we call magnetic declination. Okay, I'm just going to use a short form here, declination, and it is in our area about, generally speaking, I think it's 9 degrees, but most people just go with 10 because it's 9.1 or something like that degrees. And it's shifting every year. It's changing. So it could go from 9.12 to 9.14 to 9.16. It's fairly small shifts every year, but it is changing all the time. And we need to know this if we're looking for really detailed direction travel. But for the most part, for us, it's not that big a deal. We just go with a 10 degree, just nice and easy number. Okay, if you lived, for example, right here in the middle of like Manitoba, okay, and we draw a line here, we'd go like that somewhere, I don't know, there you would have 0 degrees magnetic declination. And if you go over here to BC, over on this side of the province or country, you can see that magnetic declination would change and it would be the opposite. Where we add, they subtract, and where we subtract, they would add magnetic declination because they're on the other side of true north. So it's an interesting phenomena, but this is how it works, and this is how your compass works. Your compass will always point to magnetic north. The needle points to the magnetic north, not to true north. Okay, so a couple other things about the map that we want to finish up before we go. One is, what is a map scale? And a map scale is the relationship between the distance on a map and the distance on the ground. If we had a map that was 1-to-1, the map would be the exact same size as Earth. It would be useless because we'd have to open it up and it would take up all the same space as what we were standing in front of us, and that really wouldn't be very practical. The map is a scaled down size. So there are 3 different ways that you can kind of find scales. And one is like a representational fraction or ratio. Okay, a ratio is like this: 1 to 50,000, and that's a very common scale for wilderness canoe tripping maps. And what it means is that 1 unit on the map, so 1 centimeter on the map, represents 50,000 centimeters on land. So 1 little centimeter, tiny little centimeter, is actually 50,000 of those in real life. And I said 500. I don't know why I got 500 here. Let me fix that. This should be 50,000 units on the Earth. Okay, and that can also be done in a direct statement. And I think most people prefer this better. So a direct statement would be saying 1 centimeter equals 500 meters, which actually is exactly the same as 1 to 50,000. So most people would prefer a direct statement. 1 centimeter on the map represents 500 meters. And that makes more sense to us because we don't think of 500 meters being 50,000 centimeters. It just works better. Now, a lot of people really like what are referred to as line scales. And so here's a good line scale. Okay, line scales are done along the bottom here. This is a good example. And the reason they like this is that they can kind of hold their fingers up to the line scale or hold up a piece of stick or anything and say, well, that's 3 centimeters or 3 kilometers, and then on the map this is 3 kilometers, and they can guesstimate distance quite nicely from it. So it's a nice visual representation of it, and you don't have to do any math, you don't have to measure anything, you just kind of look at your line scale and away you go. So I find it's quite useful. The direct statement and the line scale are my 2 favorites, although ironically many of the wilderness tripping ones come with just a uh, ratio on them, 1 to 50,000. But of course, I understand what that really means, so I'm okay with it, right? So if we go down here, let's continue down. There's something called a legend. And I'm not going to spend a lot of time on this, but it's pretty interesting. A legend's just a visual representation of what the symbols on a map mean. So, for example, campground is represented by a tent, and a picnic table represents a picnic area. The different lines are very important. So, gravel road, secondary road, primary highway, forest is green, and blue area is represented by water. Blue is pretty standard for water. There's lots of other things. I think one of my favorites is if I go like this, what does that mean? And most kids will know that that represents a bridge. So especially if there was a dotted line going through it, right? There's a trail or some sort of thing, and there's a representation of a bridge. Okay. There's lots of different symbols that exist out there, but that's just a good example of one. All right, let's continue down the note here. The compass. Okay, so we're going to go to the compass. A compass is an instrument containing a magnetized pointer, which shows the direction of magnetic north and the bearing from it. Okay, so in this particular case, the idea that we have something that tells us what magnetic north is. Okay, so I'm going to do a diagram here, and I'm going to label this diagram. Okay, and I'm going to kind of label things not just straight up and down, but really from importance. Okay, so the very bottom one is pointing here to our magnetic pointer, and this is commonly known as our magnetic needle pointer, and we generally just call it the needle. Okay, you'll notice that there's two sides to the needle. There's a red side and a black side. The red side is the side that we're interested in. That's the side that's pointing to north. So based on the way this compass is sitting right here, north is in this direction. We know that. So right now we know that that is pointing to north. It has nothing. It only knows how to point to north. So unless there's something interfering with this, that is the direction of north right now on that needle. Okay. Now, there's a bunch of other things that you should be familiar with on a compass. First of all, the whole platform that we refer to is called the base. Okay, that's this thing right here. This is pointing to the base. This is all the base all around here. Okay, it's a solid base. It's what you're going to put in your hand when you hold the compass. Okay. And then we have, I call this the direction of travel arrow. So it is the direction of travel arrow. Okay. And it is always, when we hold the compass in front of us in our hand, we point that direction of travel in front of us, because that's the direction I'm going to be facing. That's just how we use a compass all the time. All right. Now we have something here that rotates around, and we call this the dial. Okay. So this is our dial right here. And oops, silly me. Let's see if the eraser will work here. Yep. Back to pen. Did it again. Dial. Okay. The dial, D-I-A-L. And it will rotate around, and it also has numbers from 0 to 360, or N to, which is 0, and 360, all the way around. You can see them as they go around the compass here. Hopefully you can see it in the video. Okay. Then what we also have are a few other things. What we call right up at the top, this is where we read our bearing. So bearing, reading. Okay, it's where we read our bearing. And then we have two other things that are on here, and they're inside the middle of the dial. They rotate, okay? And one is a series of lines. You can see these lines kind of in here. This one's being pointed to right there. And these are called orienting lines, okay? And then we have what is known as the orienting arrow, which is kind of like a box here. Orienting arrow. And I have a different name for it. And most people, I think, they refer to it as the house. And the reason we refer to it as the house is that we're often trying to put the needle in the house. Okay, so we're rotating things so that we get the needle into the house. And when we do that, then we're in good position. And so that's where the terminology comes from. House, needle, but the needle goes into the house and we're in good shape. Okay, so we can do a number of different things with a compass, okay? And so let's go over those things that we can do with a compass, okay? Okay, first of all, we can find a bearing on a map. We want to know that we want to find where we might have a bearing somewhere on a map that's like, whoops, Windows not liking me here, sorry. We want to find, we have a spot here, we want to travel to here on the map, and we want to find what that bearing is, okay? So what we do is we lay our compass on the map right there, right beside it, right on top of it in that direction with the compass arrow here. And then what we do after that's step one, and be sure that the direction of travel is this way. If you were going to go this direction, we reverse the direction, we'd have to flip the compass the other direction, okay? So there's my base plate, there's my direction of travel. And then what we do is we rotate, and this map will have a series of lines like this that are called northing lines, okay? That's what they do, is they put these lines on a map, and then we're going to rotate the dial so that the lines in here line up with this particular northing lines, okay? So we rotate the dial to line up the orienting lines and the orienting arrow to line up with the northing lines on the map. And once we've done that, we can then pick up the compass and read the bearing from the top of the dial. Now, because these lines are going to true north and the compass is going to magnetic north, we need to make an adjustment. So we need to adjust for magnetic and declination. In this case, we would add 10 degrees to the we have to add the 10 degrees to the compass reading. So if we were to have gotten a reading of 70, we'd actually add it up and make it 80 or whatever it was, okay? So I'm not doing an actual example here, so you have to kind of work with me on that. I might do a video where I do an example of each of these three things here, okay? It's a little harder to do because it's hard to see the details of these things, okay? Then the next step would be, next question I'm going to ask you is, what if list the steps to be able to travel. I tell you, I need you, wherever you are, you need to travel, 2 kilometers and at a bearing of 135 degrees. And you're going like, oh, what am I going to do, right? Well, first thing you need to do is take magnetic declination into consideration, because it's always these bearings are almost always given to you in true north bearings. Unless they tell you otherwise, you assume it's true north, okay? So you adjust by subtracting 10 degrees for magnetic declination, okay? And this will get you to 125 degrees. Then what you're going to do is you're going to take your compass and you're going to rotate the dial until 125 is towards the top of the direction arrow. And that's pretty easy to do. You just hold it in your hand and rotate the dial like this until you get 125 right on the top. I don't know if you can see me here up in the top corner doing it, but I got to look at it here. 125 is right at the top, and I'll point that right there. That's 125. And now I'm going to hold the compass flat, okay? So I'm holding the compass right flat, and I'm going to actually walk around until I get my compass needle into the house. And I can't show you this because if I don't hold this perfectly, flat, it's not going to work. But you have to trust me that when I rotate this, the needle keeps pointing that way. The needle keeps pointing to north, but the compass rotates until I get the needle in the house. Once I have the needle in the house, that's the direction. The arrow at the top of the compass is the direction that's telling me which way I have to walk or go. And usually when I'm standing in the wilderness, I'm actually rotating my whole body around it to get myself into the direction I want. And now I'm facing in the direction I need to go, and off I start marching. I got 2 kilometers. Now I got to have some way to figure out how far 2 kilometers is, but um, I can kind of hike in that direction. If I start wavering off from one side to the other, I'm going to lose my bearing and I'm going to be in a different place, and that's not good. Okay. All right, so the last one is what if I'm standing somewhere in the wilderness and I'm traveling in a particular direction and somebody calls me on the cell phone and says, "Well, what direction are you traveling in?" And you're going, "I don't know, I have no idea." Well, you need to be able to use your compass to figure out which direction you're traveling in. Okay, so what you do is you stand holding the compass flat out in front of you in the direction you are traveling. Okay, then you rotate the dial of the compass, okay? So if I'm going in this direction, I hold the compass out like this and I rotate the dial until the needle goes into the house. And I keep rotating. You have to trust me. I just put the needle in the house right there, okay? And now I can see what direction am I going in, okay? My needle's moving a little bit on me, and that's normal, right? Sometimes hold it out in front of you, and there's a reason for that. I'll explain that in just a second, okay? So now I can look at the top here and I have a bearing that I can tell them I'm traveling at. Okay. Now, technically, technically, I'm actually, you know, not, I'm traveling magnetic north. And in order to do this, I have to add, I believe, 10 degrees. So if I want to, give them a true bearing, I have to add that 10 degrees to it. But even just to be able to tell them within 10 degrees, I'm doing really good. Okay, so I'm reading that from here once I've rotated my needle into my house. And that gives me the direction of travel that I'm going in. All right. Well, one thing you should know always is that any metal item can disrupt my needle. That includes electronic things as well, like a cell phone or a watch or anything. You have my watch on, and I'd have to be very careful that I used my hand without my watch. Otherwise, I could mess up the way my needle points, and it can shift it off 20, 30 degrees quite easily. It doesn't usually get it to spin 180, but it can sometimes get it to spin off a fair bit. I've known of people who have been lost in the wilderness, and a large part of the reason they're lost in the wilderness is because they're they're misusing it. Something metal is pushing off their compass, and they think they're in good shape, but they're not. So keep in mind that compasses are, compasses like these are affected by metal objects or electronics for that matter as well. All right, that's the lesson. I might try and do another supplementary or complementary video on this, on actually doing some of this on a map, but it is somewhat challenging, and we'll see if I can actually get something to actually work that you can see.